And John, if you permit me, we just started the overall view again, just overview whatever we told in the last session and continue briefly along that. And if you had a question, just interrupt me anytime that needed.
No, it sounds great. Okay. Yeah, and if we start giving you information overload out there, we apologize for that. We kind of realize everybody's at different places, especially these first couple lessons. As we get going, we'll be more in the same frame, but it'll take us a little bit to all get there, I think.
Let me go slightly from the. Do you see the picture that I showed you screen, SkyNet?
Yep.
Okay, and I want to overview again SkyNet and my core WebAssign that we had here. Although I registered it, but I want to go briefly on the beginning. And you just need to do kind of search for the WebAssign Signe login. And also same thing for SkyNet. Let me go to the beginning. SkyNet UNC. And there is another SkyNet exists that is not important for us, but the SkyNet UNC and also WebAssign Signage is an important one. And also you see another WebAssign here. We don't care about those. Only these two is important. First one is mainly the curriculum of the course and steps and labs, the practical applications that we're going to review on astronomy. That is going to be main introductory and curriculum of the project and the activity that we're going to do. And SkyNet is only for the observation and taking a picture from the celestial sphere like planets, galaxies, and dwarf planets and solar system and so on. Then let me go over the first one quickly. Here, as I have assigned it, normally you see it on different computers and different operating system is different. But I assign it, you have to click here and sign in based on the password that you have it. And you can change it, the password you use the ID as needed. But if you had a problem, just text it to me, send it to me, my email, I will figure it out and resolve. And then right now you go on the dashboard. And when you go on the dashboard, you see on the left side my courses. And the courses that you're going to see, Astro 100L, University of the North Carolina, Chapel Hill. And when you click on that, this gives you the whole set of the chapters that we're going to review here. It's lab 1, 2, 3, 4 to 9. And this is kind of uh, items that we're going to review that are going to go later on this. And also SkyNet, when you click on that, you will log in. I already log in and it is, I have to log out and do it login again like this. And you put user ID and password and enter. In here, normally, if you don't have any observation, you're going to see empty spot. But because I did observation before, I see the previous. When you submit observation, it shows here active. And when the picture is taking, they say completed. And you can look through the pictures that you have taken. For example, M104, I click it. This is a picture that I have it. Therefore, we're going to look through a detail what's it going to process to work. But basically, we have different things, the homes, SkyNet Live, telescope site, and help. But the main things that we're going to look through it, this is my observatory and optical observation. And the important things that we have here, add new observation and afterglow. This is the post-processing. Right now, we don't need it. Later on the next weeks, we're going to overview this. But the first thing that you need to do to go and add new observation. And as I mentioned, add new observation has 5 steps. You specify the target, filter, telescopes, exposure, and review. Just things that you need to do. For example, I quickly go over it. I specify Jupiter here, and the program itself find the Jupiter, and you assign a name here. For example, I put Jupiter, my initial date is 0.9 2025, something like that, or something that is designate your observation from the other ones. The important things here is this picture that you see it here. Let me go over another items here. Just unshare it and share it again to open that file. Uh, just give me a second. To open. Okay. Right now, I share it again the screen. Okay. I hope you see it my screen at the moment. Again, I share it. Let me. I forgot to share it. And control share. Okay, that's good. I want to make sure that if we needed to have video, sound is also active. Okay, then the things that we have it on here, as I mentioned, this is kind of overview of the sky in a circular way. It is kind of part of the um, celestial sphere. To imagine this one is a little bit might be difficult in the beginning, but you will I will show you like this. This one of the simple pictures that will show the when you are in the somewhere outside of the home and looking the sky above your head, you see it that all of them is you can imagine all of them is located in a kind of celestial sphere far away from us. For that imagination, we can consider we're gonna review it this one on the next labs, but I'm gonna give some very quick review. This is our Earth. Whenever you are located on the Earth, when you look through the sky, it seems to be all of the stars and celestial objects are pinned down on the kind of a dome, like we call it a celestial sphere that we can locate and measure those. And whatever you see it on your top of your head is zenith, and whatever you see on horizon might be in horizon. You will see some mountains or some buildings or trees. It's not like free like this. Therefore, you cannot access or all of them. But anyway, this gives you some impression how the star is going to be looked through it. Back to the or a picture here. This is the same way it shows you uh, a dome above your head, but you see a circle here, but it will try to make it in a way that is observable. Right now, you don't see anything except sun because we are a daytime. We have to go, and right now you see here daytime time. This is a Eastern time zone. If you have different time zone, you have to see it probably accordingly. They are just programmed when you upload it directly. You don't need it to worry anything. And then you just added hours. For right now, 2:42, and sorry, this is 12, 1, 2, and through, let me see what happened. It's shouldn't be AM. Right now it's PM. Let me see, something is wrong. Let me do it again, search again. Okay, right now it's specified, I think Eastern time zone. I have to change my time. Something is wrong. But anyway, I don't want to spend this one. That might be because of my computer problem. Here, when we go down, this is day, day, day. And the item that you're choosing here, for example, Jupiter, it's going to show it by circle a plus sign inside it. But here you don't see it anything because it's daytime. We have a sun on the sky. We cannot observe. And immediately when sun is sunset, right now, sunset, it's gonna see everything. You're gonna see not only Jupiter, but other object. You can zoom at it and see whatever you see it beside the Jupiter. You see the Crab Nebula M1 and also Pleiades M45 beside it. You don't need to worry. You don't need to zoom it also. The only things you needed to do, provide the keyword here and search, and it's going to provide for you something. You provide here some name to designate it for you 0209 2025, something like that, whatever is comfortable. And then the next thing you're going to do and go save and choose the filter. You complete the first item to identify the target. One item that is important just for the visual sense how it works. You don't need it to worry about learn anything on here, but this line at the bottom show the horizon, and this line, gray line here, show the minimum elevation above the horizon that the Jupiter or object that you target can be seen. And you see here, some of them here, you cannot see much. It is going to be about half an hour here, about half an hour here. But other telescope is about 2 hours, 3 hours. They can see it on the night. For example, this observation NSO cannot observe in here about this time. Why? Because it's daytime. And probably it has to pass about 1 or 2 hours after sunset to start the observation till the time go to the set uh, about below the 30 degree of the horizon. You can adjust this one a little bit, make it 20 degree. When you do that, you see the line here, it's gonna below. It becomes, it originally was here, it become here. Anyway, you have more opportunity to see it. Recommended to have at least between 20 or 30, whatever is good to choose it for this case. And then we go to the filters here. To target filters, the filters, I mentioned that last time on the course, when you go to the course and click the view, in there is a kind of this is a kind of curriculum of the course. All of them is by video. For example, if you see the introduction, you can review original enhanced video here that is Dan provided, and you can look through it whenever you have a time. And some instruction, overall instruction about the location of the telescopes and kind of how they gather the data and take a picture. For example, light comes here, reflected here on the secondary mirror and goes back to the field about the filter and the kind of digital camera here to show the filter. And this is kind of very symbolic way how the color is going to look through it. You don't have to worry about that or memorize. Just give you a sense of how this physical things works. And this is the item that I mentioned to you earlier, how the observation gonna work on that observatory. And then in here, you see some tables. For example, for the observation of the Jupiter, for example, this is a cheat sheet that provided based on the practical experience of the astronomer on the SkyNet. Therefore, you don't need to worry about memorizing. You can look through this later on or copy on the Excel file, keep it for yourself as a memory and look over whenever you need it. Here, it specifies Jupiter, you specify filter U and duration 0.5. Then you go back to the here you see a bunch of filters, you see it. How many? There is many filters you have here, each of them for a specific purpose. You don't need it to memorize, just plug it, click it, whatever you needed. Before clicking you see the telescope is available to observe here. But when you select U, some of them become inactive, cross it out. It means that this telescope doesn't have U filter. Therefore, they cannot take a picture and program automatically choose for you whatever observable and needed. You don't have to worry. You just click here, U, and go to the next. In the next, you finish the target, you specify the filters, you choose the telescopes. Here, you can choose any of the telescope. For example, this is Perth in Australia, in La Serena, Chile, Mecklenburg, Australia, and Chapel Hill, North Carolina, or Saskatchewan in Canada. Any of them, you can choose it. Or the other option is that you can choose the all of them together. For example, there is an icon to see it, dot in the middle of the circle. It identify when I click it, you see all the telescope is selected. Then I will go and save and go to next. Therefore, you select the target, filters, telescopes, and right now we're reaching to exposure. You always select the generic 16 inch telescope in here. The reason is that all of these numbers is given adjusted based on that this generic telescope. And if in some cases you choose another one that's gonna be mess up on your exposure. Here on the exposure, you specify, I wanna take a one picture, one exposure, filter is U, and how much the duration? 0.9 second, 0.5 seconds, 0.5, and then it active, everything is done. Therefore, you just save it and continue. Therefore, this 5 step is simple like that. Target, specify target, filter, telescope, exposure. Most of the things you don't have to memorize, except the exposure and filter number that you have it on the WebAssign. And the remaining is directly computed by the program is developed on the SkyNet app that you had here. You can, the last one is just review the name that you assign it, the target you make it happen, and some basic information, maximum some elevation. We specify directly by the program because we don't want a sun on the horizon and take a picture and the picture may not be good. We're gonna make sure the sun about minus 12 degree below the horizon that we're able to see it. And then the other options we're gonna look through later on. This is identify how many telescope we can take at this picture that we choose. How many we have right now?
7.
7. Okay, but it means that 7 is available, but it doesn't mean that he's going to take a 7 picture. Uh, Based on the kind of rating that they have, probably one of these telescopes reach to the position they take a picture of the Jupiter, for example, from 6. When they take a picture, then release other ones. The other ones gonna go do other activities. Therefore, this is kind of programmed by the program. You don't need to worry about that. Here, for example, this is a credit that I have. Total cost gonna be 1, and then submit. Therefore, this is kind of very brief review of the activity that you can do it on a SkyNet. And when you do that, you will see it on the observation, something is Jupiter is active. Therefore, when Jupiter is active, it means that it is on process. It's not taking picture. It may take 5 minutes. It may take 5 hours. It may take 5 days, or it may take 5 weeks to take a picture, dependent on the uh, kind of weather condition. Telescope is working. Sometimes telescope is just had some technical problem. They are closed, like the one that you see it here. They are locked or closed, although the atmosphere is good. Here, the atmosphere bad, but it cannot take a picture properly. Therefore, the program itself get those data and get ready your observation as needed. This is kind of very short review. I just repeated again. Sorry if every you have known that and you see it. But any questions so far you have on this item?
Boss, where was it you did the naming scheme? We kind of went through that before. I think you
Which
skipped
one?
where you put the name of your observation. I have that in my notes as far as when we save our image, take the image and you put the name in.
Yeah. Okay, let me share it again, that screen.
Like the last step, wasn't it?
Yeah.
Yeah. And I was wondering about your naming scheme. What do you,
Here, you mean when you add the observation, you mean the name here, right?
it's right there. And so you've been using the name of the object and you put the date in.
Yeah,
It's,
you just you can add your initial or you add any other thing that, but make sure that all of them has to be either letter or numbers. It cannot be you can delete the blanks also to make it more clear. Therefore, this is kind of things that recommended by Dan and Skynet to observe. Is that the question I answered correctly, or you asking something else?
yeah, I just kind of reinforce this as we're going through things. There's some things which
Yeah.
are good to have in place later on.
Yeah, that's correct. Yeah, always keep remember because if you you take a picture of Jupiter 5 times and all of them you call it Jupiter, then you will lose which one of each one. You have to click each of them and go to the data and see what the purpose of and what the parameter you identified. But if you give it some good indication for the observation name and the object, it will be great. Okay, thank you, Krish. joining. And hopefully, we're recording this one. And if you missed others, you can join after that, listen the videos. I didn't able to put on the email videos that we had last week's, but my plan is that by end of today, you're gonna have those as well as I send a separate email for everyone for Zoom link for all 3 sessions that we have on the week to have access to that. And John and I, we try our best to make it as possible. We provide more flexible on the uh, more hours assigned, although this course is free and neither of us get paid for that. And but all of us at least we get fun and get some excitement on our moment when our work eventually. Any questions so far? Hearing none. I go again to share the other object in the course. Okay. Uh, the one that we had it here, as I mentioned here, I'm going to go to the observation lab here a little bit to identify some other thing. One of the key items that we have to remember when you take a picture, although the program check it, weather is good and telescope is good and camera is good, everything is good, but sometimes the picture may not come true. Although you use 1 credit or 20 credit or 100 credit, you may get something like that. It means that suddenly the weather has become bad, unexpected, and or kind of some either other issues uh, happen in some part of the image, like the one that you should be like this, become like that. Therefore, this is not useful. You cannot do anything on that. Therefore, it is out of your control, sometime out of the machine and computer program control. That is kind of things that eventually happen. This is the things that never AI or computer program can get you the best option. The human checking, you have to check it always, the picture that you're taking. If you see it, the picture not going good, you do it again. For example, if I go my list, I will tell you this one also. If, for example, the picture I take it from Horsenet Devula, you see, this is very bad. And therefore, I know that this is not good. The only thing that I need to do, resubmit. When I do resubmit, it brings everything here that previously done and I have to check it to see if I did mistake, I identify something that is not correct. Then if it is needed, just go to the proper section and change the filters or exposures and then review and resubmit. Therefore, to resubmit, you don't need it to enter all of them. It is automatically saved in your system. Therefore, you have to always, after your observation, check the data. You have to observe those. And sometimes, for example, this is a mount is uh, just irate or doesn't follow the Earth rotation. Here you see the focus on the telescope is not very proper sharp. And here shutter on the camera is not properly open up and closed. And here you see probably some source of the light, either from moon or something else, causing the misbehavior of the picture. And sometimes you see a satellite passing by or airplanes, and then, and sometimes you see a bug here. And that's a good kind of, although it is good picture, it's gonna be very exciting for the social media to see it. We can not only observe the stars and galaxies, we can observe the bugs on the telescope as well. Anyway, this is the kind of next sections. As you see it here, all of them tutorial are there. Let me close and show it to you one more time. This is all the before opening. Everything here you can close and open as needed. Each lab, because of that, we call it lab or not chapters. The reason is that because you needed to do some activity. And there is a tutorials exist for 5 of them. I ask you to go over, and if you have a question, just back to us. And also there is a kind of for each lab, you have this one. It gives you some overall goals that what's the intention from this lab. Equipment, you needed only computer And this is a site, observational site, and the other uh, historical background and how the prompt telescope works that I explain it. And this is maintenance. Sometimes with maintenance needed. We needed some issue, and then they inform us. Some of the observer they tell us there is a problem on the prompt. It's not some always directly email the people over there to inform. And sometimes this network, there is a network of the individuals that's supporting each other and working together to address these issues. But the main thing comes from the procedure. When this is a procedure that I explained it to you and the minute ago, I don't repeat it again. The next step is checking the picture quality that I explained it, and you can go over it. And then uh, observe the planets. For example, I started with Jupiter. You can start with any of them. But remember, at the moment, probably you may not able to succeed to Saturn or Neptune because they are very close to the sun. And you may able lucky to get it either of them, but it is very on the borderline. Therefore, all the others, you don't wait for next 2, 3 months to take a picture. Just start taking picture because next day or next week there might be it's not visible. The picture that you see it like this is Jupiter, Saturn. You can zoom it on the afterglow that we're gonna show later on. And here also for the observe the moons, observe the moon of the Jupiter, Saturn, and Neptune and Uranus as well. And for those, you see the parameters a little bit changed because those are very faint object. You have to use filter high true. High true here. Let me go to the filters here. High true is only for the very faint object we're gonna use, and because of that, in here it identified for this object for the moons of the Saturn, Uranus, and Neptune. You needed to use high tune. And for the moons of the Jupiter, instead of the U, you need to use B as well. And this is one similar picture that taken by the moons of the Jupiter. You see the Galilean moons, and here, and then observe the dwarf planets. Here, dwarf planets also very faint, very far away. One of them, Ceres, the biggest one on the asteroid belt, another one on the Kuiper belts that we're gonna show. We're gonna explain those a little bit and further distance to give some basic astronomical information about the various objects on the solar system as well. But for Pluto, you need to have 80-second exposure. You need to gather 80-second photon from the telescope to able to observe it. And this is one of the example here. Although you see it airline passing through it, sometimes you need it to poor quality and you have to reobserve it. If, for example, it goes past directly the item that you needed when you zoom it, that's gonna block the object that you're gonna see it. And then next step, the deep sky observation. Here also you see the duration are much higher. Probably for this one, Crab Nebula, you needed to spend 75 credits to make a picture of that. And this one, 60. The lowest one is the Trifid Nebula and the Orion Nebula that has a bright objects. And therefore, you don't need it that much exposure. And similar for the star clusters and galaxies, you needed more time for that. But anyway, this is very selective things that I provided here. And I just stop here at the sense. Have any question so far? Okay. John, do you want to share something? Do you have anything about that 4 minutes, or you think is ready, or you pass it for the next time? I have something else I can add it if you don't have.
Yeah, just going forward, just remember we have meetings. We'll meet always Tuesday and Saturdays, and then this Sunday afternoon's a nice catch-up time too. And things we'll probably be talking more about in the future and just throughout right now is if you've not used Stellarium, Stellarium is available as a browser. It's also as a download. And the browser is very convenient in that it pops up anywhere on your phone, anywhere. You can see where things are at and really quick get their locations and check them out. But the download version has a lot more options and it's much more robust. It takes a little bit to figure out what you're doing, and it will just basically take over your entire browser. So the whole screen, it'll kind of lock it up. You can still get to other things on your screen, but it'll take up the whole screen. My caution on Stellarium is it has add-ons. So you can add on more and more libraries of really deep sky objects and more faint objects. And I would encourage you to wait and just download when you download that program, I encourage you to do it. It's a great astronomical program to use. Just download the basic and wait until you really need to add anything else onto it. Big reason is it has so many files that for some computers, it can really load you down. So if you've got a new M2 computer, M3, M4, something like that, that really can take it, that might be different. For a lot of us, you might just start off really small with that because a lot of the programs we're using will take a bit of memory on your computer, a lot of your RAM. Stellarium, a great program to use. It'll help us to kind of see where things are in the sky. Um, I do have, if you don't mind watching me in a video years ago on YouTube, I did make a series of videos on what's called 1 degree of sky time when I was first learning how to do the video stuff on YouTube. And it does go through like how to do right ascension and declination. I try to make it very simple. I try to make it at an elementary level. So anybody could watch this and kind of figure out how the sky rotates, what the ecliptic means, what declination and right ascension are, and what is 1 degree of rotation of the sky. So if you don't know what those are about, do a Google search or YouTube on 1 degree of sky time. And some of the videos I know are outdated because they were relevant to things that were happening at the time. But the basic ones, which are like what is the ecliptic, what is 1 degree, will teach you kind of what the coordinates mean. And Dan does a good job in his lessons of explaining what right ascension and declination is also. But I try to integrate that with Stellarium and Eyes on Space from NASA and different things to make it really simple to understand and kind of see how the sky moves so you get a feeling for this. I think in a lot of these programs, as we start working with SkyNet and stuff, you should start to see how the sky is moving, how things are going, and it should become a little bit of a common sense. And then I do love how in SkyNet has so many nice, useful tools like how the weather is at different spots and things like that. We want to learn those. So some of these observatories are at such high altitude that weather's not going to be a problem. They're above the cloud line. But then some of these, like I was looking at, like Chapel Hill, Moorhead. Okay, you're in, Raleigh-Durham area. You're in a light congested area. I don't expect phenomenal images of deep sky objects from that observatory. And I knew we have to watch the weather and such. And some of the others are located strategically and some in dark areas and some aren't. And so that's one thing we're going to have to learn about these observatories. It's which ones take the best images for what we're doing. And that's where the chat is really nice. And also with I always forget these social ones, which one it is. But we do have,
Group
uh,
me.
yeah, in the group me. And I can send out that link again as far as
Yeah,
how to get that.
I sent it. Is actually, John, thank you for reminding. I added the links for all this Stellarium and also WebAssign and SkyNet on the email that I sent it about an hour ago. That have a Zoom link and everything in one spot, and hopefully you save it and use it later on as well. Thank you. That is good also to have a chat. If you had a question, you can join the group me and ask either. Sometime John is available, John answers. Sometime I am available, I can answer. But sometime both of us busy, and you have to wait for another hour or so. We can catch up and get back to you.
And I think we've been reiterating the idea that just start off with anything, just do your first observation, that'd be the biggest challenge. And then after that, it should be pretty easy to do the next ones. As far as objects, Jupiter, as far as planets in our first lessons, Jupiter is going to be the easy target. It is farthest from the sun. And then it kind of goes, they all get closer. All the stars except for Mercury, are basically up in the evening. But just realize Venus is the next farthest out of actually that's not really true. I think is it Uranus or Neptune? One of those two is out there a ways too. But all the others are creeping towards the sun. And so we'd really want to get those observations in soon. Venus will be the next easiest, but then we won't be getting Mercury, but Saturn is really close. And so realize you're not going to get all the planets imaged this time. And Saturn, forget it for the next, 3 or 4 months. It's not going to be the right place. I did put on my calendar, though, that Mercury, if you want a shot at it, I think it's March 9th or 10th, something like that. It goes back out in the morning sky, I believe. So it'll be coming into view. So although that won't get done in the next couple of weeks, I do think I'm going to keep that on my radar to go back so I can check off that one that I've been able to image it with the SkyNet.
Yeah, thank you, John. That you make a good point that I forgot also reminding us, all of us, that we cannot we have some schedule for object that we can observe, but it means may not be observable at this time. But we have to look around on the next months or so, or next 5 or 6 months. That is this course gonna go by May. To see if we can make it. Sometimes that 5 or 6 months also you are not able to observe certain object that is very close. But as much as you can look through it and make it on radar, and also the schedule will be great. And also, I forgot one thing. Yesterday, there was a very good opportunity for kind of last night or night before. We have a transit. The Jupiter's moon's transit from the face of the Jupiter, and then it was cloudy here. We cannot do anything, but I wanted to observe myself. But in addition, that kind of things, you cannot control the telescopes on that particular items. That is very precise. Timing is needed because you assign take a picture. You don't say to telescope which time specifically you're gonna take. You're gonna take whatever is available. And that's only things that you can control is that you have a telescope in your backyard, you do it yourself. Therefore, that's kind of difference that we have with the remote telescope and also the telescope that you have in your backyard. And John, if you wanna, I will share you some Stellarium also that's gonna be helpful for learning also, uh, as you pointed out. If you agree, I agree with that. I guess
That
let
was
me
good.
share the. Okay. Here, you see Stellarium, but when you click Stellarium, I send a link on the email for you. As John mentioned, when you click on this website, you see various versions available by Linux operation system, Mac, Windows 34, 64, and also Windows 10 Plus, and Stellarium here as well. You can use this Stellarium web, or I recommend to download it proper version that you had. And when you click it, it brings you see it asks you wants to access your visiting allow this time or always allow. Then agree here. Then you just make it a little bit zoom to make it more area in here. As you see it here right now, uh, you can see the timing and the observation based on the data that you have. You can provide some coordinates here or remove it or some other coordinates. We're going to look through it later on this. And sometimes you needed to put the constellation pictures on the mythology or kind of constellation asterisks lines connecting the main stars. But the thing is that when you go outside, this is one of the challenging things when you start astronomy. You see something picture on the screen right now on computer screen or your book or social media, but you cannot sense a 3D view of the things. For example, if I look through it, this is looking through the north, and I just moving around to east, and this is the south. The one of the easiest object that you can observe is Orion Nebula. But you see a bunch of stars, how you can recognize, and you see sometimes the satellites is moving here as well. But how you recognize this Orion? When you add the line, there is no line over there. You cannot see it, the line. This is a line that your mind is comes by imagination. Therefore, only things that is very obvious here, if you can look through the moon and the brightest planet, it is almost on top of your head. You can see it almost, you see it downward, you come toward the south, and you can see it, this constellation. And main object of this constellation is it is kind of hunter that has a belt, has three dots, three. I can zoom it in and zoom it out. You see these three stars that is showing the belt of the hunter. Let me bring it this picture, like the one you see, this hunter. This is a belt of the hunter, and this is a kind of various ancient time figures that they have, clothing that they use. You don't see it. You don't see this. You don't see any line, but you have to imagine to see, to recognize that by these three dots. And that three dots is very good here, because when you extend it on this side, you see the brightest star on the sky in the location right now is the time is about 7, 8 p.m. On the Eastern time. Probably you're gonna see it about the horizon on the southeast direction. And when you extend it other way, you're gonna reach something else about the Pleiades here, and also the Jupiter that is very good recognizable by unaided eye. Without telescope, you can see it. And then on the other side, you see the moon and the Mars. The Mars is very good to recognize because it's red color, and Jupiter is very bright and blue-white color, and you can easily recognize. And if you go back here, you see the Venus on the near to the west horizon. But the Saturn a little bit further down. If you had trees or buildings here around your view, you may not able to see a Saturn, but you can see it Venus. This is kind of overall view how to use the stellarium, and we're gonna show you later on how it's gonna work. This is kind of very simple designation of the uh, um, item that I show it to you here. This is kind of uh, celestial globe that is on above our head. And this is exactly the stellarium show us the same way. And you can orient it as needed, that look through it as on the consideration. But you can rotate it as needed by mouse and look through around the different locations, different horizon. On the north, you're gonna see the Polaris here. And you know the direction of the Polaris, you can recognize it by this way. If you look through this is one of the good measurements tools on the astronomy. Uh, how many degrees of a circle? 360, right? Then if you look through the one part of the object on the sky, for example, between two stars or between the two objects, you will see it with the angular dimension. Same thing I specify here. For example, when you look through the height of the north celestial pole or north Polaris, it's gonna be create an angle with the horizon. This is the same angle you see it here. And these angles are, when you take it with a simple formula, you can find the distance here that you don't need it to memorize. You're gonna look through it on next phases of the labs on the class. But this is kind of very overall review that how the Stellarium works. I recommend for you, and also when you take a picture, you just come change the date. For example, you can change date here. Let me, for example, change date for another hours, and look through the compare to your picture with the time that you take it. And you, for example, when it is daytime, you don't see it anything. And here is date night. Daytime, you don't see it anything. And again, become early morning, you see it. Therefore, this is kind of opportunity. You can change a date for 2000 before and 2000 after. easily you can get what the sky looks through it. And that's a very good tool and very credible information most of the time had it for checking your data on that. But I recommend to you to get used to it outside, look through by naked eye, unaided eye, to recognize constellation and May eye shape. And that's gonna be first lesson to you to learn practically what's the object. And if you had a question, let us know on that.
Okay. Hey, is it
I hope
okay,
this
boss?
overview gives a good kind of introduction. Hopefully, everyone not
Boss, can I
overwhelmed. Go
I
ahead.
share my screen and go through that a
Sure.
little bit too? Is that okay?
Sure. Yeah. Yeah.
I'll try
Perfect.
to, I got Stellarium up also. I'm gonna try to, hope I get the right one.
Sure.
Share this off. So a couple of quick little lessons. If you, for some of us as we go through this, I'm gonna turn on at the bottom where it says equatorial grid, and you're gonna see these lines go across. And this one is marked 0 degrees. And so that is like looking out on the solar system. And that's what's called the ecliptic. So just a real quick lesson here. Um, if you look at the width of these lines, each one is marked up here at the top as like 7, 6, 5, 4, 3 different hours. But that's an hour of separation. So if you take your hand and you stick it up in the sky, everything in the sky will move that distance across in the width of your hand in 1 hour. This is an hour hand. And I'm looking at like the moon and Jupiter, Uranus, and Venus, and I see like they're all above that line right now. So they're a little bit above the ecliptic, and they'll go above and below as such. It's about 15 degrees also. So 15 degrees is about an hour. Um, what I see that's useful here is I'm looking at this is actually, I think, tonight, and I think it's from in this area. I'm seeing that Saturn's really low, and I see Venus is really low. So that tells me, as far as trying to observe those are really close to the sun. I see Uranus is way out here, and I know uh, we've got another one up close too. So Neptune is real close to Venus also. They're like we're all in this area. So these are objects that are close to the sun. So when we start using these observation tools, SkyNet, they're going to be tough to get because they're really close to the sun. The good news I see though is the moon is over here, and the moon will always move the other direction. And there's 24 hours in a day, and it takes it about 27 days to go around the sun. So each day the moon moves one of these lines away from the sun, so basically towards the east. And so I'm looking like if I wanted to observe Jupiter, it's a little bit away from the moon, about 30 degrees. It'd probably pick it up. And Uranus is good, but like Venus is great. And a couple nights from now, moon will be way out of the way and it'll be better and better to observe. So that's how Stellarium can be kind of a handy tool for here is by looking at its location compared to other things I want to see. If I were to zoom in here and I'm going to start to see other stuff come in, and then I'm like, oh no, well, Mars, I'm not going to observe Mars right now because Mars is right next to the moon, and the moon's just too bright. It's going to wash out the whole field. But, 2 or 3 more days is going to be perfect because the moon will be farther away. It's going to be, but, so planning out my observations, I'm thinking, oh, I want to image Jupiter here in the next couple nights. And then a couple nights after that, I'll probably want to image Mars. And I definitely want to image Venus, and Uranus is right here too. I definitely want to image it. And later on in the year, we'll be looking like for different objects like Pleiades and stuff. Or Orion, it's going to be, watch that moon and watch the sun. When they're not close, we want to make sure you get a chance to observe them. So just a little mini lesson on how right ascension is the part that goes across, like your hours, and up and down is called your declination. And so it's a lesson start going forward. We'll start talking about right ascension and declination. That's what it is. Right ascension is back and forth on the east-west. Declination is the up and down. In your hand, that's an hour or 15 degrees. So hopefully it wasn't too much information, but a little bit to explain why what we'll be doing as far as coordinates, how that kind of works with Stellarium.
Thank
Any
you,
questions
John.
on that?
Thank you. It was great.
Short and sweet.
Any question? We are about 5 minutes left from our today's session. If you had the time to go over, and if you had a question, just let us know. And then about the uh, item that we discussed. And also, I want to emphasize another thing is that let me share this one quickly. As As John mentioned on here, probably as you see it on the uh, latitude and longitude of the Earth, the whatever coordinate system we have on the sky, on the what to call it, the one that is described by John, it is going to be extension of this one. For example, this zero is shows our equator, like here, equator here. Extension of the Earth equator, it's gonna be celestial equator. Extension of the South Pole, gonna be celestial South Pole. Extension of the Earth North Pole, gonna be electric celestial North Pole. And also in addition, extension of the longitudinal, it's gonna be uh, uh, what do you call it? The uh, uh, I think the right extension and extension of the latitude gonna be uh, the declination, that how much away from the horizon is that. And as John mentioned, very good, that we needed to just not memorize, just keep looking through it in the same way to get to used to it and learn like the one that we looking to the longitude and latitude. The same thing we look through the right ascension and the declination as well. Any question?
Well, thank you everybody for joining us today. Really appreciate that. And
Thank
always
you.
here, so feel free to reach out if email or through the chat if you have any kind of questions we're going. And if you're learning little tricks, because there's a few tricks I've been picking up, but they're worth sharing as you need them as we go.
Thank you. Thank you, everyone, and hope you have a great rest of the weekend and enjoy your time around. And wait for me to send you the video after the recording and process. Thank you.
Yes. Now, if you're an Eagles fan, it's a thumbs up. If it's a Kansas City fans, it's a thumb down, right? Or how's that go?
Thank you.
Yeah.